Okay, so I welcome you all for this discussion. So smart irrigation system using IoTs. So first thing, we need to use some sensors to identify the plant conditions. Again, we need to process that. We need to some microcontrollers. Again, we need to provide some Wi-Fi facilities to make the data to be available in cloud. Again, this should be done in a real-time manner. Okay, let us start with this discussion.
So I'll give the introduction about this project. So agriculture is the main part of the economy today. So traditional irrigation methods leads to water wastage. So let me introduce here a microcontroller which is Arduino, where it controls the water and drips like drip irrigation. So let me ask someone to use that.
How will you please use the way? Soil moisture, the soil water level. If the moisture is really restored, the layer will be activated and it will answer the pump so that the moisture of the soil can be given. If the soil reaches threshold, it can supply pump.
So I'll give the components of this project. So it's Arduino, which is a microcontroller, and the soil moisture sensor, and relay, water pump, and also LCD. These are the components used here, and also the power supply at last.
I'll tell about the advantages and disadvantages of this device. First, it is cost effective as it is a small in size. It is a cost effective one, and it is very scalable also. And by using drip irrigation, you can save water too. And its limitations are it cannot work long in battery, and it doesn't give correct results. So it has to be updated more.
We some future goals for this project. Actually, IoT integration for the remote monitoring of this system, smart irrigation system. Use of the sensor for smaller control than available one. Use of solar power for rural areas because many farmers are feeling difficulties for planting their crops and cultivating it for a long time. So it will be a useful one for the future growth. So it must be implemented on the area in many villages as well as urban areas.
Again, we use multiple sensors so that we get a complete field will be covered. So we take an array of sensors. Again, we can use this moisture sensors. Again, this threshold levels. So multiple threshold levels may be required so that we can turn on and turn off the required level of waters. Again, we can consider this growth. So for that, we can use some more sensors also. That will be given better results for that. Okay. Again, IoT platform. So continuously it monitors the information and that should be updated. So based on that, how many amount of is consumed, that can be, we can monitor it. Whether it will be required or increase or decrease, that can also be decided.
By using the modules like Bluetooth, Wi-Fi, JSON modules, LoRa, we can connect it remotely using smartphone. So it can be maintained. We can maintain or control it from anywhere.
So what are the uses of microcontroller in this project? Microcontrollers actually access the analog values from the sensors, process the inputs and converts the input to output to the logic unit, and it controls the timing level. Actually, it is a 16 megahertz and 32 kb flash memory. So it uses the C and C++ program for this project. So actually, these microcontrollers are the main component which is used in this project to maintain the time difference for the water supply, for fertilizer supply, so that the crops can be cultivated like a landline one. So this will be a future project if microcontrollers are developed furthermore. This is used in this project. In this CD, you can see the sensor data and the other information used. Using this only, you can see the results and output of this project.
So let me tell some real-time use case. One use case I will say. So medium vegetable farm scale in Tamil Nadu. Let me take a 4-crop section of agriculture where it drips irrigation. Farmers will leave their land unattended. So it will give the crop yield by 45% and reduce the water usage by 80%. So it leads to crop yield also and reduces the water usage. So if it's implemented in the future and also with updates,
things. So we need to consider sensor. So normally sensor will be interpreted in a digital form or analog form. So digital form only we get in binary results. That is whether it will be having a water level or not. So that is not suitable. Here we use this analog manner. So we use an A to D converter. So we get an exact levels of the things. Again we can fix multiple thresholds. So based on that we can turn on or turn off it. Again display devices we can take an LCD displays. Again we take some relays to turn on and turn off the things. So because whatever the things results will be, that will be updated in a cloud. So not only that, the device also should display the information. So for that we can use some LCD displays. So what is the present condition and how long it will be turned on and turn off. Again we can include some energy consumption. So how much energy is consumed. Again how long it will be available and what are the time cycle of the motor is on and off. Everything we can record. Yes. Thank you.